quickly. If your group happens to know an answer, you tell it to me and I hear it from you first. I'm willing to give you a point each. I don't care how high your point's in today, but we got some math to get done. Monday there is a math workshop test. If you're trying to take that early or whatever, you can come see me later today or whatever it is you need to do. It's fine if you wait to take it after the break. I do not care. I won't type in zeros until probably the end of the following week. The math workshop test is a 100-point grade in the 60% category.
It's a what?
100-point grade in the 60% category, just like it was last time. There are 20 questions, 14 of these. Oh, I'm telling you hints now. 14 of them are factoring. 14, that's well over half. 4 of them are radicals, so like, can you simplify this radical? Then 2 of them are like 14 and 15 of can you use your laws of exponents? So needless to say, it would be nice of us to not only go over the factoring, but really to go over 1 through 16 and let go of the 2 word problems. There is no word problem on this math workshop test. That is good news. Okay, so let's start with number 1. We've got to make our life pretty fast today. See if we know the answer to 1, because if you don't shout it out pretty fast, I'm going to start telling you. Yes, if we factor out an A, we're left with, you can all point, A plus 5 plus B. And that is the answer. That's all we could do. Number 2.
It can be 2x.
If I do grouping and I factor out a 2x from the first group, I would be left with a 4a minus 3. What can I factor out of the second group? Point for you then, ma'am. Negative 3, and you're left with a 4a minus 3. So my final answer is 2x minus 3, 4a minus 3. Number 3, easy factoring. Leading coefficient is a 1. Need something that adds to 4 and multiplies to 4.
2 and 2.
So z plus what and z plus what? Oh, it's what? It is. Steph, get a point. 2 and 2. 2 plus 2 is 4. 2 times 2 is 4. So really I could write this as z plus 2 squared. And relating this back to what we've been doing graphing-wise, that would be a kind of quadratic that only crosses the x-axis once. It only has one x-intercept. Number 4 I love because it's the difference of perfect squares. The answer is, say it again. Yes, and 2b plus 25. Perfect. Because 25 squared is 625, 2 squared is 4, so that is literally perfect. Number 5 is a hard factor because there is a 5 in front. There is going to be some hard factoring ones. Say it again, dear. Okay, x plus 3. Okay, but they can't both be pluses.
X minus 3.
Okay, so let's try this out. He may or may not be right. I like to do guess and check. If you want to do bottoms up, it would still work on this one, but we're out of time, so I can't do both. 5x squared for the first, minus 15x, plus 3x, minus 9. There's one tiny thing we need to change, although I am going to give 6 a point. We did not get what we had. There's a tiny thing I need to change, and it is the sign. They both need to be minuses. It should be 5x minus 3 and x minus 3. Then, if we fold it out, we would have 5x squared minus 15x minus 3x plus 9. Hey, that's 5x squared minus 18x plus 9. That's what we had to begin with. So that is the correct answer. Again, if you want to slide, divide, bottoms up, that's fine with me. Just don't have time to go over that method again now. Okay, I'm going to slide paper over, but try to zoom out so those who are still writing can see it. Number 6. If I factor out a negative 7, I'm left with w plus 4, w plus 17. Thank you, Jake. Point for you.
17.
On number 7, I heard it. It was Eduardo. Okay, good. And I'm going to do, because there's 4 terms, I'm going to do grouping. I can factor out a 2x, so I'm left with a 5x minus 7y. In the second group, I factor out a negative 3, point for you. And I'm left with a 5x minus 7y. Yay, my two parentheses match. My final answer is 2x minus 3, 5x minus 7y. Number 8 is an easy factor. The leading coefficient is a 1. I need two things that add to 12, multiply to 12 and add a negative 7. 6 and 3 get a point. And it's going to be d minus 3, d minus 4. Negative 3 minus 4 is negative 7. Negative 3 times negative 4 is positive 12. That is completely correct. 19 is another difference of perfect squares. So the answer should be... I know it's a 4, but tell me about the other part. 6 can have the point. It's 4 minus w squared and 4 plus w squared. We still have to do the exponent. The x4 is still a perfect square. So it's 4 minus w squared and 4 plus w squared. 10 looks like a hard one, but there is a trick to it. Can someone tell me the trick on 10?
It's not even.
No. It is a simple.
Not that. It's what's it called. What's the word?
There is, don't do it, you'll lose a point. There is a DCF. I can pull out a 3. If I pull out a 3, I'm left with a 5n squared minus 9n minus 2. And they set this one equal to 0, so I guess I'm actually supposed to solve. I don't know if we actually have time for all that today. We can. So there's a 3 on the outside, and now I'm going to do guess and check. I know it's a 5n and an n. I've got to figure out, I need it in the middle to add a negative 9. I know things that multiply to 2. It's either going to be a plus 2 and a minus 1 or a minus 1 and a plus 2. I don't have that many options except on where to put them. So I'm going to guess that it's a
plus 3.
A minus 2 here and a plus 1 here. I'm literally just guessing. That's how guess and check works. I guess. If you want to bottoms up it, we can check it on out too. So I'm going to FOIL this middle out. 5n squared minus 10n plus n minus 2. Hey, that is 5n squared minus 9n minus 2. I'm not crazy. That is the correct guess. Now, since it says equals 0, should I keep going and get my two answers of negative 1/5 and 2? Probably so. But Lord knows I'm out of room, so I'm going to let it go. Okay, those were our factoring ones. Again, the first 14 are factoring. I know we went through those fast, but factoring should have been pretty fast by now. We've been doing it for a while. Okay, let's get to these radicals because they are a pain. There are 4 radical problems on your test, on your next math workshop test. Let's see, number 11 is 3720. That's a big old number there. I need to know a perfect square that goes into that. What did you say, Mackenzie? Did you say 9? 9 didn't go. Nine didn't work, 16 didn't work, 36 didn't work, 64 didn't work. So I'm just going to try 4. Yeah, that's 930, but you'd think something bigger would go. Let's see, 4, 9, 16, 60 times 62, but neither of those are perfect squares. Yeah, but neither of those are perfect squares, so how are we going to reduce the radical? Because I'm trying, I tried 36, I tried 64, I tried 81. Okay, well, I know 4 goes in, so I went in my calculator. 3720 divided by 4, I get 930. So I know it's at least 4 times 930. Now, I'm not saying I couldn't have done better, but my gosh, at least I got something so we can move on. The square root of 4 is 2, so 2 square root of 930. Again, I make no promises, doing this on the fly. There, 9 and 30 might not be, there might be a bigger option. There probably should be, but I cannot come up with it on the spot today, sadly enough. Okay, but I've left off these exponents and I've got to add them in. So if you can help me figure out what exponents to put where, like it's q to the watt power. Thank you, 6. You can have another point. Q to the third with a q left over. 3 times 2 is 6, plus 1 is 7. And then it's r to the
12.
2 can have the point. 12 times 2 is 24. So I'm going to leave it as 2 q to the third, r to the 12th, square root of 9/30 q. Now, am I going to maybe miss 1, maybe 2 points, simply because maybe there might be something bigger besides the 4? Maybe. I don't know. The 324 is really nice, though. Well, number 12. Why is that? Yes, Mia, it is a perfect square. And it's 18. So 5, 4, and 6 can have a point. It's 18j to the 10th. 6 can have another point. Okay, number 13, we're raising this. So again, there are 14 factoring, 4 radicals, and 2 only laws of exponents. So when we raise everything to a power, we multiply our exponents. So it's negative 2 to the third, you get negative 8. Negative 2 to the third, you get negative 6. C to the 9th. When I raise powers, that's what they're doing when it's raised to the third, I literally am multiplying my exponents. So negative 2 times 3, negative 6. 3 times 3, 9. I had negative 2 raised to the third, but I'm smart. I worked that out. Negative 2 times negative 2 times negative 2 ends up being negative 8. We're going to skip 14. There is not one with a fraction that I know of, and I swear if there is, I'm going to change it.
Would you want us to put that in like a decimal form?
No, I would leave it as a fraction. Yes, I would. I would leave it as a fraction. The only reason why we might want to practice some part of 14 is because of that negative exponent. So let's pretend the problem was just f to the negative 3. What would we do if we had a negative exponent? We can't leave it that way. What are we supposed to do with it? Where do you send it? Send it to the bottom, so it's 1 over f to the third. I kind of gave you that one, so I'm going to keep that point to myself. If we add all these exponents on 15, 1 minus 6, negative, yep, you get 9, table 6. Thank you, have another point. And this is p to the fourth because we subtract. So if we're multiplying, we add the exponents. We're dividing, we subtract. Only if we're raising a power to an exponent, like on 13, where everything was raised to the third, do we get to multiply the exponents. Okay, that was really fast. Are there any major questions about that? Because you're in math class here.
Oh, you heard that before?
Oh, yeah. Open your packet to page 24. Yes. Open your packet to page 24. Okay, you were asked to try, and I haven't checked it, and to be honest, because life is what it is during first period, I probably won't get to check it until Monday. You were asked to try 5 completing the square problems, and there were 3 on your checkpoint. I'm probably going to be nice and post the 3 answers to the checkpoint on Google Classroom. That way, when you return, at least, whenever I see you next, you at least have those 3 answers. We pray. We pray. There is a quiz on Monday. 2 of the problems are completing the square. One is an easy completing the square, and the other one is a hard, meaning that the exponent is not a 1 in front, a leading coefficient. I'm sorry, not exponent. The leading coefficient is not a 1, which is what we discussed yesterday. So if you tuned out yesterday, my gosh, I pray you watch the video and get it together. On Monday's quiz on completing the square and quadratic formula, there are only 2 completing the square. There are 3 quadratic formulas. It's only a 5-question quiz. If that super concerns you, there's good news. There is a bonus available. It's called the Completing the Square Turkey Bonus. I'm going to pass it out to those who are here next week. If you're not going to be here next week, but you would like it, just see me and I'll gladly give you one in advance. Completing the Square Turkey Bonus. Okay, I asked you nicely to last night at least think about memorizing this formula. The hardest part of the quadratic formula is memorizing it. I literally don't remember whether or not I sang you my song. I'm pretty sure I did because we had a whole discussion. Good, I'm not singing again. If you're... It's so terrible. It's so bad. Maybe. If If you don't like my song, but you need a song to memorize, watch YouTube. Mr. Moore made his kids watch it on a 15-minute loop one day. He is crazy. Okay, we're going to skip 1 through 5 on page 23, which is what Paige was concerned about, so her group can have a point. We're going to skip page 23 because that's Seth's homework. He's got to do page 23 by Monday. Seth, or whoever it is going to be here on Monday. You got 5 problems to practice the quadratic formula on. It's not a big deal. Literally, I'm about to do 5 in 5 minutes. I'm that good. Okay. Page 23 is going to be your homework. 23. 1 in your alma nurse.
In the workbook?
No, in your notes. Page 23. Okay, let's go to page 24. Those are the ones I'm going to work. Okay, so to humor you, all I need to do is know this formula. If I know this formula, the rest of this is easy. Completing the square is a pain in the rear. You have to know how to do it, but a giant pain in the rear. Anytime I actually get to choose in life, I choose the quadratic formula. So it was negative b, plus or minus square root, b squared minus 4ac over 2a over 2a. And literally, if you know the formula, you know the rest. So let me tell you about the formula a little bit, and then we'll work out our 4 problems really fast. Okay, so this is the quadratic formula, and it's going to still help us figure out those x-intercepts. And we still have those options of our graph might have 1 x-intercept, our graph might have 2, or our graph might not even cross the x-axis. So it might have 0 intercepts. We still have those 3 cases going on. And what's really cool with the quadratic formula is you actually know before you get to the end of the problem, you know which kind of case you're dealing with. So the first thing we're going to talk about is a vocab term that is useful to know. It's called the discriminant. The discriminant is actually inside our formula. It's the part under the square root. So for us, the discriminant is b squared minus 4, well for everybody, b squared minus 4ac. That is the most important part of the formula. That tells us everything about our graph. Because if we get, for instance, a pretty nice number, like square root of 49, life works out beautifully, and we end up having a positive and a negative solution. So if you end up with a number under the radical, life's good. You're living in that 2 solution land. If you end up with a 0 under the radical, which is possible, well, if we had a 0 here, there would be no need for that plus or minus. Yes, ma'am.
I'm going to remind you to post attendance if you haven't already.
Yes, ma'am.
Thank you.
Okay, so if it was 0, then that whole plus or minus situation would go away, which is why we would only have 1 intercept. And then you and I both know that I've told you over and over again not to forget about this third option. If our graph never crosses the x-axis, then we're living in imaginary number land, which means we're going to have a negative number under that radical, like negative square root of 6, negative square root of 49. If you see a negative under the radical, I already know, hey, my graph is not crossing the x-axis today. And so the good question would be, well, Ms. Compton, why do we have 4 problems then? Because I'm assuming you're going to work one like this, one with a 0, and one with a negative number. So why are there 4? And that would be a genuinely good question. And the answer to that would be, we're going to have one where it's a pretty number under the radical, like a 49, and we know that's 7. And then we're going to have one where it's an ugly number under the radical, like a 3. And that's when we had to do the second calculate, and it's going to be a decimal answer. But I don't want your decimals. I literally want you to leave like 2 plus or minus square root of 3. That's what I want. I'd rather that than a decimal. Okay, so let's go to number 6. The first thing we do is find the discriminant. We want to find the value. And that's not even true. That's not the first thing. The first thing we do every problem, the first thing we do every problem is this in standard form? Because if it is in standard form, you and I both know A is -5, 4 is B, and 1 is C. But if it's not in standard form, we have to put it like this first. So again, that discriminant is the part that's b squared minus 4ac. So literally, I'm just going to plug in my numbers and chug out an answer. B squared is 4 squared, minus 4, a is negative 5, c is 1. So I have 16, because 4 squared is 16. Negative 4 times negative 5 is positive 20. So I have a pretty number under my radical. So my discriminant is a pretty number. So if you're reading, it says there's a part A, find the value of the discriminant. There's a part B, describe the number and type of roots. Well, because it's a pretty number, I know my graph is going to cross the axis twice, so there are 2 real roots. So even though you and I have yet to graph anything, and we've yet to actually solve and say, like, it's crossing here and here, simply from knowing the value of the discriminant, I can already tell you a lot about the graph. Okay, and part C is to actually, plug in the quadratic formula. So if you want to write it every time you can, I'm literally only writing it today to help those who are struggling. So for us, negative b would be negative 4, plus or minus, and it's over 2a is negative 5. Now, I could do the b squared minus 4ac again, but we're smart. We've already calculated that. We already know that number is 36, so I'm literally just going to plug in the 36. But I know the square root of 36. It's 6. So I actually have negative 4 plus or minus 6 over negative 10. And if you wanted to in your calculator from here, you could do negative 4 plus 6 divided by negative 10. Negative 4 minus 6 divided by negative 10. I don't mind working it out quickly by hand, but again, you can always calculator it, especially if you remember that frac button. So for me, I get 2 over negative 10, that's negative 1/5. So one spot, my graph crosses the x-axis is negative 1/5. In the other one, I get negative 10 over negative 10, which is positive 1. So the other spot where my graph crosses the x-axis is positive 1. So we're just chugging out math now. Everybody in here can do this. It's literally, does Arturo pick the correct A, B, and C? If he does, there's no way for him to mess this up. Well, everyone can make typos and errors or whatever, but there really shouldn't be a way for him to mess this up. Are there any questions about number 1? Okay, well then on number 2, again, first thing we're going to do is that discriminant. If you calculate the discriminant, again, it helps me know a ton of things about my problem. So b squared minus 4ac, our b is 22. What's our a? 3 gets the point. What's our c? 1 gets the point. I need this calculated. 22 squared minus 4 times 1 times 121. I need to know what this is. It is, you get 484 minus 484, which is 0, which means we got a square root of 0. So there's no plus or minus land, which means we have only one answer. We're only crossing the x-axis once. So for part B, I know I have one real root. And again, I've not actually calculated, Seth was the point, I've not actually calculated anything. I just know from my discriminant how this goes. Do we need to go for 2?
If we take 2, that's his fault.
Okay, so again, part C is we're actually going to plug and check it out. Get it together, we got to hurry. So for us, it's going to be negative 22 plus or minus over 2a, a is 1. I don't have to calculate that b squared minus 4ac. I've already done that. The answer was 0. I can just plug in the 0. So I have negative 22 over 2, which is negative 11. Darn it, I'm so sorry first period for lacking in the way it is. I swear I'm going to finish it all in second period and third period. I'll post the video for them all. You need to watch something. It's as easy as it gets, but darn it, where did my time go? on my back.